Okay. And the things that are done well by the system are, for instance, the fast analysis of data, making different judgments on the data, and interpreting data really quickly. Those are skills that artificial intelligence is doing much better than humans, but humans have a lot of skills that are especially in the problem solving and social arena that really are currently much better done by humans than by an AI. So what I'm really trying to push for in this discussion is trying to see how we can find that hybrid intelligence paradigm and find the optimal relationship between what humans can do in these learning and teaching scenarios and what the artificial intelligence can do and where the additional added value is for all of them. So from that hybrid intelligence paradigm, I think it's important to start thinking about these fluctuating borders between AI and artificial intelligence in order to find these different optimal balances and articulate our thinking in such a direction. And that really aligns well with what we call the augmented reality, the augmented perspective on artificial intelligence, where we really try to push for the actual boundary to find that interaction in an effective way, and not so much think about AI taking over particular aspects of the learning and teaching profession. Now, if we pave out the pathway towards a hybrid AI, human AI interaction, it's quite unclear where we are today and where we can be going. And there, I think the model from the car industry can be quite informative. This is the model that they developed. Yes. And in this model, you see a number of important steps. You see the transition from a self-driving car, from a driver-driven car to a self-driving car, and you see full automation. Can you see my mouse? Yes. You can see full automation on this side of the arena. And what is interesting, I want to point your attention to, is the upper line here. And that is really discusses the role of the human in interaction with the artificial intelligence. And so in initial driving, both controlling and monitoring is in the hands of the human. But as we transfer to self-driving cars, we see that humans first monitor and then control is actually transferred to the system. And the car is actually taking over many more steps of both monitoring and control of the human. And that is envisioned by the line here going up. And so initially humans are assisted, then they are partially supported, and at the end they are actually fully capable. And what is interesting here is that this transition point here is a critical point of transferring the control and the monitoring between the human and the system. And this is really where the challenges are that we view today. This model for the car industry has helped the car industry make explicit what the steps are, where they are today and where they can go in the future, and how different elements of self-driving cars are in fact contributing to an increased control of the car and this transition between human and AI control. Now, in a similar vein, the medical field has used this model as well, but there it had an additional layer. It was not only pointing out the pathway towards self-driving cars or the use of AI in medicine, but it was also inspiring an ethical discussion about where the field in fact wanted to go. Did they envision themselves as fully automated doctors? And where was that boundary? And I think for the field of education, we can ask the same question. Where is the boundary? How far do we want to go in the transition between control and AI, between human control and AI control? And what is the most optimal way of aligning this within our application area? So in order to progress that discussion, we developed this model for education. And so you see the same 6 layers, where here at this side, we have teacher only, and here at the other side, we have full automation. Now I want to point your attention first to the underline here. And as you can see, there are multiple little lines going into the model, and they represent the different data streams that we use in order to fill the model with. So you can use one single data stream, which we often do. We use log data, or you can actually engage in multiple data streams. And later on, if we think about the restrictions and where we want to go, this could also be an interesting discussion about which data streams we need in order to progress across this model. Now, if you look at the upper layer, this is really about that transition of control between the human and the artificial intelligence. So in the teacher assistant mode, you see full control, both hands on the wheel, as well as full monitoring from the human. And we see that we transition across less hands on the wheel and also less monitoring from humans across the different stages. And what is important, and this is similar to what is currently under development in self-driving cars, is that at some point you see that there is a transition of control. And that means that the system also starts talking back to the human at stages where that is necessary. And I think that transition is a really critical one in our field as well. So I know this sounds quite abstract, so let's dive into the model, and I'll give some examples from my background at the different stages. And I really want to point out they're only examples. So I also really want to invite you to think about your own technologies and prototypes and where they would fit within this model. So if we think about teacher assistance, the technology provides supportive information, but the teacher has full control and monitoring capacity himself. And as an example, I think teacher assistance is represented really well by different levels of dashboards because they describe and they mirror student behavior to the teacher, but the teacher still enacts full control over the activity that is over the response. So the system as such, the AI doesn't take over any particular tasks from the human in this particular situation. What is important though, a lot of people would say, where's the AI? In dashboarding, well, there's quite a lot of classifiers being used currently in these dashboards that actually aggregate and put a different level of intelligence on top of the information communicated. And I think the model that's being used for dashboard research, where we look at mirroring dashboards, guiding dashboards, and recommending dashboards really reflects those different levels of interaction with the user. And I think in the future, we'll see that dashboards will engage more and more classifiers and elements of artificial intelligence communicating information back to teachers. So I think this is a really nice example where there is artificial intelligence, but really not taking over any tasks, but really providing information to users in order to help them to act better within different applications and scenarios. Then if we move to partial atomization, we move a little bit across that arena. So now the technology controls specific tasks, very small tasks still, and the teacher monitors everything. But there is a transition of activity from the system to, from the human to the system. Now examples could, we're going to the end right now. Let me get that back because that would be a bit too quick, I would say. And examples would be, for instance, the use of artificial intelligence for object recognition. As you can see here in this particular example, the system recognizes the chair. By that recognition, it is possible to activate a particular activity that is, in this case, the sign language for a particular chair. And in that way, the system describes a diagnose and it enacts a very small task, namely the recognition of the chair in this particular topic and the activation of the particular information that is needed for that. Another example of partial atomization are adaptive learning technologies that are used widely in primary schools, where you see that the technology is in fact providing information in the dashboards, as I just showed, but also making decisions about the optimal pathway that students should take. And in this particular example, the technology actually selects the next best problem for every student to work on. So the topic that students are working on is set by the teacher, but the next best problem for this particular student to practice with, is selected by the technology. So you see that the selection of the learning material for particular students is taken over by the technology, whereas the overall control of the orchestration of the classroom and the information that is being worked on is still handled by the teacher. So you really see this transition where the technology not describes, diagnoses, but also enacts very small steps within the scenario, and it clearly notifies its teachers of what it does and how that is enacted. Then we have conditional atomization. This is where the teachers monitor incidentally and can resume control at all times, but the technology is taking over a broader set of tasks. So it's really taking a more comprehensive role in this learning scenario. And therefore, the technology also starts to signal much more to the teacher when support is in fact needed. An example of that, I think, are intelligent tutoring systems, where you see that they describe, they diagnose, and they enact. And ideally, they also notify and advise teachers. And I know this is a development that's only been, has a relatively short history. So within these scenarios in which intelligent tutoring systems are used, both step feedback is given to the students. So the initial feedback on particular assignments is given by the system, as well as the organization of the curriculum. So also the adaptivity of the curriculum is organized by the system. So here you see the connection between both direct feedback, elaborative feedback, and orchestration of the curriculum activities for particular students, which is a much wider role for the technology compared to the example that I gave before. And teachers are much more on the back, transferring these roles to the technology. Another example that we could envision within this arena is also the double teaching scenarios that you see under development, particularly in China at this point in time, where the actual artificial intelligence here on the screen is taking over the orchestration of the classroom, determining the goal and the pace of a particular lesson, when the teacher is supporting that, doing the individual interactions with students at the local level. And there you also really see this interaction between the teacher and the artificial intelligence, trying to take over different roles and assigning different activities. So within conditional atomization, this transition is ongoing, and larger sets of activities are actually enacted on by the artificial intelligence. Then if we move further across that line, we go to high atomization. There actually technology can take over the support of learning for a number of tasks. So technology plays a pretty autonomous role in order to teach particular domains. Teachers monitor and control is not required for those specific tasks, but there could be tasks where the technology is not capable of supporting learners, and that's where teacher control support could come in. I don't think there are too many examples of this yet, so I'm taking one from the people that we know well in this community. I think this presentation trainer that is developed by the Open University is a good example of a high automation. It provides direct feedback on a number of different elements of the presentation that students are giving. So it's on tone of voice, it's on posture, it's on movement. And in that, it's pretty autonomous, but it doesn't really, or at least for as far as I have seen so far, it's not capable of judging the general storyline of a presentation. So this is typically the domain that teachers would still take over. So in high automation, there is description, diagnosis, and enactment, but still a particular section that teachers enact as opposed to the system. Now, if we go to full automation, we're talking about full autonomous systems, really without a role for teachers and learners. I think there are a few examples in informal learning. They're not nearly as effective as I think we want them to be. I think a very good example is the Leo system that is being developed for second language learning and culturalization, where you really see the full loop being enacted automatically. So you really see these simulations that provide personalized feedback, pick up on the language used, try to adjust the material to the needs of the students, align the curriculum to the needs of the students, and provide additional practice that aligns well with the needs of a particular student. So here we see the description, the diagnosis, and the enactment, fully autonomous. It really steers learning in an autonomous way. And I think these examples are hardly found or not found currently in formal learning settings, but they're mostly developed in informal learning settings and language learning, where you really see systems developing towards these fully automated versions. So this gives you a little bit of a description of how we see the model and how we could envision the pathway from human learning technologies towards human AI technologies. And you really see that this balance is the balance between human control and system control. And I think that is really the core discussion of this model. Whether you want that balance and what does that balance mean for the different scenarios that we're enacting within classrooms. Now, what I'd like to do is give you the opportunity to see where your prototypes would fit within this model. So I don't think I have the controls for the polls, but somebody should have those. And I would like to launch the first question. Yes. So where would you position the prototypes that you're currently developing? And I know that that might be multiple options. So I think probably choose the one that is most logical or most important to you yourself. And I would like to see where we are and get a little bit of an idea where we are as a field. And also while we're getting the polls in, thank you for responding. This is great. There's also the opportunity to put your technologies and prototypes that are under development on the Miro board so that we can get a little bit better idea of where all the technologies are that we're currently working on. I think we have 39 responses. Well done. Could we also share them with the audience? Yes. So it's really nice to see that there's a nice division across the different levels. There are quite a few that are working on teacher assistants, and I'm aware of that work with dashboards. Then there is partial automation, conditional automation, even high automation, and I see two that are doing full automation. I'm super excited to hear what the examples are. So please put them on the Miro board so that we can later on in the discussion revisit these different topics. So thanks so much for interacting. Now let's continue and have this discussion if we envision the market at scale. So if we could stop sharing, thank you. Who's taking control of this? I have all of you. Lena, thank you so much. Really appreciate your help here. So if we think about this a step further, right now we thought about it from the perspective of our technologies that we are developing as research groups, and that are typically the prototypes that we play with. But I would also like to ask you to think about the usage at scale in educational institutions in your countries. So if we go to usage at scale, I think from my perspective, we have quite a few examples of partial automation in primary education in the Netherlands, where we see around 60 to 70% of our schools working with adaptive technologies, such as the one that I'm showing here on the screen, but also different ones. So there's quite a large uptake of this particular technology in classrooms across the country. So you do see a partial automation at scale. If we look at another technology that has been taken up quite a bit, it's the intelligent tutoring systems. Not so much here in the Netherlands, but I think in the United States, we see quite a development on intelligent tutoring systems such as Matia being used in the classrooms. So there are a number of examples that we can give of technologies that did make it into the market. And I'm kind of curious to hear what your perception is about the position of technologies used at scale in your country. So if we could fire the next poll question, Elena. Yeah, oh, this is working well. Could you, this is a, haha, this is a third one. Sorry, I mixed them up. Could we fire question 3 first? We'll leave it, well, never mind. We'll just ignore what is on top of this. So presuming that we're talking about what is being used at scale, which one is, do you see at scale in your countries? And also the invitation to put them on the board under the second layer of the Miro board. And I think we can end this poll to share results. We see that there is, again, a division across, but there's more emphasis on the first layers, although there are quite some examples, obviously, of conditional atomization at scale as well. So I'm really looking forward to seeing them appear on the board to see what we have at different, in different countries being used at different levels in the educational systems. And let's see if we can revisit that after the main part of the keynote. Thank you. Then, and that was the mix up with this question. I think it would be really interesting to also think about what the ultimate role of AI in education will be. And we can think of that from the advancements on the 3 critical elements that as a community we'll probably need to develop in order to see how we're going to move forward towards a more advanced role of AI in education. And in my view, there are 3 critical elements that drive that transition. As much as with the self-driving cars, it is important to follow learners and track their activity within the environment. And that's probably one of the most important critical factors that will drive our progress within using AI in education. Second, we need to be able to diagnose learners' current state and anticipate on their development. So really try to push forward our understanding of diagnosing the data that we are collecting. And then, and this is probably the most difficult part, we have to develop our ability to consequently determine the appropriate actions that are needed in order to optimize learning. So I think the speculations towards the future and the ultimate role of AI in education and in teaching depends very critically on those 3 abilities that are envisioned also in this slide a little bit further. The first one is the ability to detect and to use different data streams in order to do that, to diagnose this in an appropriate way, and to then determine what is the best possible way to enact on the data and the diagnosis that we have encountered. So if we dive into these different domains just a little bit deeper, we see that detection can be across multiple data streams. So that's the layer underneath in the model. Traditionally, we have focused and we have a lot of experience in our field with log data and to some extent mouse and keyboard data that have been used across the board to detect learners' behavior. I think we see an increase in the use of physiological data and eye tracking that are being integrated in order to detect student behavior and the environment. And of course, video data and voice data increasingly are becoming available to us as sources that we don't need to analyze ourselves, but can be analyzed to an extent with artificial intelligence. And that allows us to use these different data streams in a different way within our learning scenarios and technologies as well. So we really see that the scope of detection is increasing quite dramatically, and also the field of multimodal learning analytics has been addressing this question: how can we use these multiple data streams in an effective way within our technologies in order to further advance our ability to detect and track the environment of learners? And I'm very much aware that this has an ethical component as well. So that could also be one of the discussions in the end of the keynote. If we look at diagnose, I think there has been the development of a number of generic algorithms that we've been using. In the Netherlands, the ELO algorithm has been used a lot in our adaptive learning technologies. That's the main standard that we have. If you look at intelligent tutoring systems, mostly use Bayesian knowledge tracing algorithms and knowledge graph algorithms in order to adjust the material to the needs of the students at many different levels. What I think is a relatively new development is the development of content-specific algorithms that we've seen developing over the last few years. For instance, algorithms that specifically detect students' technical reading ability with eye tracking information, algorithms that detect dyslexia or dysgraphia with different features from different data streams. And I think that is a relatively new development as opposed to the more generic algorithms that are being used in these systems. And I'm quite interested to see what the balance will be between the more generic applications behind technologies and the more specific algorithms that can enhance different, very specific elements within the technologies as well. And then if we look at enactment, of course, there are the visualizations that we already talked about in the model. If we expect technologies to take over tasks, generally what we see today is that they take over tasks that are related to cognitive behavior of students. So we see that they either provide step feedback within particular tasks, like that has been developed within intelligent tutoring systems, or we see that there's task feedback where their tasks are being selected for learners, or we see that the curriculum has been optimized following different pathways through the curriculum. What I saw when we analyzed the arena of skill technologies is that most technologies do one thing well. So they either provide really well step feedback, or they are capable of supporting tasks selection, or they are doing really well at curriculum level. But the integration of these different activities is problematic, and it's also really difficult to integrate it in a way that it actually enhances each other. And you also really don't see that as much at scale. So I think one of the challenges ahead here is to think about how these different levels of adaptivity can be supported within the different technologies and how that moves forward. And another thing that is, I think, very clear from this analysis is that technologies really tend to focus on the cognitive elements. So they're really good at developing models of knowledge from students and determining what the next step is, but they don't really focus so much on the motivational and regulational aspects of learners. So the focus of these technologies is still relatively slim in their enactment. Now, in order to confuse you a little more, this is the question that was posed already, but let's answer this now in the third poll question. What, in your view, is the most optimal form of AI in education? And I'm quite interested to see how you feel about that.
I think they already answered to that, right?
Yeah.
So now the one missing is, where would you position technology used at scale in your country in the model?
Yeah, but I think we said that the other question was, well, answered in such a way that they, well, let's otherwise.
Okay, I can launch again that one if you want, but
thanks.
I don't know if relaunch, yes.
Maybe just launch the third one and we answer as if it was this. Oh.
Yeah, exactly. Thanks, Roland.
No problem.
But this works as well. We can also do it like this. Perfect. It's still quite a diverse picture coming up. Can you end the poll? We started off with a lot of activity here in the first two levels, but right now you see quite a diverse picture of people thinking that we should even go to high automation, perhaps even to full automation. There is a preference for the in-between versions where there is more of a hybrid human-AI interaction. I think this is one of the questions as a field that we should really address and think about what is the most optimal way of using artificial intelligence in education, and also have that dialogue with teachers and practitioners, because it really helps us to position where we are as a field. All right. Before I will open the floor for questions, I will really briefly, but only really briefly, explain to you what we're going to do with hybrid AI human regulation. So I'll talk 3 more minutes about that, and then I'd like to open the floor for questions. As I said earlier, the discussion that we had of the model right now is mostly from a teacher perspective. And obviously from a student perspective, it's really important as well to think about what we on and offload with our technologies. And there has been a tendency to offload regulation activities from the technology to the students. And that's problematic because it really prevents students to enact these regulation activities. And from that perspective, it could harm deep learning and future learning for students. These self-regulation activities and skills are really important for students to ensure that their learning is grounded well within their existing models, and also to ensure that they will be able to learn in future activities. So from that, we'd like to develop technologies that really help learners develop these regulation skills. And we plotted the model that I just showed from detection to diagnose to enactment on to supporting self-regulated learning. We're trying to diagnose self-regulated learning with different algorithms during learning activities, and then provide students with information about their regulation, both in dashboards as well as adapting the algorithms within the adaptive learning technologies. Now, without going into detail in the mark of time, the ultimate idea of hybrid human AI regulation is that we come to transfer of control from the artificial intelligence to the learner. So if we detect that learners are capable of monitoring and controlling their own learning to a larger extent, we transfer control back to learners and support them with dashboards that mirror their own behavior. So in that way, we really develop a system that fluctuates monitoring and control activities between the student and the system in order to support the development of self-regulated skills by learners and push them forwards across these different abilities. So that really short is what we're going to do within this new ERC grant that we're working on, and that will look a little bit like this, where we have a similar model, just from the other way around, where we have different layers of regulation and control from AI on this side and self-regulation on that side, and the transition of control through different layers in which students first focus on monitoring and then also focus on taking over control over their own learning activities towards developing self-regulated learning activities. So here we use that same logic between the control between the system and the artificial intelligence in order to transfer through learners' trajectory of learning self-regulated learning skills. And we have similar challenges as the ones that we developed before, namely that we need to identify these SRL activities during learning. We need to design that hybrid human AI regulation, and then of course start looking at the effectiveness of these different layers. So to conclude, we've been talking about hybrid human AI technologies and propose a way to frame them and discuss the use of AI in education. I positioned that on the 6 levels of atomization models to describe the roles of artificial intelligence, the teachers, and to some extent the learners. We discussed how existing technologies strongly focus on detecting log data and diagnosing students' knowledge, mostly by taking over one of the adaptivity modes, so either STEP, task, or curriculum, and that the challenge is to expand that, that focus. The frontiers for using AI are really in using different data streams, diagnosing a range of learning characteristics, such as, of course, self-regulation, but also emotion and motivation are important, and adjust accordingly. and move towards the integration of combined multiple data streams to offer new ways to diagnose and move forwards to new applications of personalization of learning. This is what I'd like to share with you. And I think this is a good moment to open the floor for questions if there are any.
Yeah, thank you so much, Inge, for this very inspiring, interactive, and maybe even partially automated keynote. I was actually wondering a little bit whether we were already, with all the contributions, feeding some AI engine in the background with the data we provide, but I guess this is probably not the case. I think we have already seen some discussion that popped up in the chat, and one particular question that you partially answered from Marcel Schmidt's raised already some discussion. So maybe Marcel, are you still around? Do you want to ask it, or shall I just read it out? Okay, you have no microphone. So the question is basically, did you consider in your model a third dimension where beside the teacher and automation, also the student will get some control in the whole process?
Yes, I think that's the struggle. So good question, Marcel, thanks. The first model really focuses on the interaction with teachers. It's also because my main focus is within K-12, so it makes sense to put that teacher in a very central position. The second model that we're working on is the shared regulation model, where we really think about the relation between the learner and the artificial intelligence and how that can be used to transfer control and also to position the control and monitoring activities. The integration of the two models is still a bit of a challenge. So very happy to discuss ideas about that and see how we can further think about that. We could think of a three-dimensional model, but I don't think it will make the world much easier. So I'm very happy to hear creative ideas from your side to see if we could integrate the two.
Yeah, I also see now. I mean, there are some questions that have been raised from the chat, and also some people raised their hands. So I guess we give the floor first, or a bit in interchanging order, to questions from the chat and people in the audience. So now I would, I think, Daniele, you were first raising your hand.
Good morning. Thank you very much for the interesting talk. So do I understand correctly, do I read it correctly, this model can be read as a maturity model for AI in education? Because if that would be the case, I guess full automation is kind of the end, the vision somehow of this model. And I just think that read it in this way, so discussing about to what extent the AI will be fully automated can leave us a little bit disappointed. Just taking example of self-driving cars, of, for example, Tesla, that has been evaluated a level of automation way lower the expectation, right? So my other question would be, shouldn't we maybe talk about to what extent, how to better somehow put together the capabilities of AI with humans, and how to make a best benefit between the two?
Yeah, and I hope that that is the message. So it's definitely not meant as a maturity model, but more as a model to think about where we can optimize this interaction between humans and artificial intelligence. And I don't think the model has a value about where you are in these different stages. Every stage is equally important. And I think at every stage there are multiple opportunities to use artificial intelligence in an intelligent way in interaction with education. It's just, I think it helps us to position where we are and what we focus on within the field of education. So I would definitely not be an advocate of driving for full automation. That's also something that is clearly discussed in the paper that I wrote about this. I think this should really help us determine what are the optimal different ways of using artificial intelligence in education without driving for a full automation model.
Thank you.
Okay, I take the next question then from the chat again. I see two questions or two contributions that I see slightly connected from Joanna Gillet and Vanessa Echeverria about giving control to learners. It might make a difference if we're talking about primary school children or university students when it comes to giving control to students. The challenge is when the teacher, but also the student has some control. How do we set those boundaries? Who has the power to decide? Is there any hierarchy?
Yeah, super good questions, and definitely dependent on the age and ability of the students. So I definitely think that should be driving force. And indeed, that comes back to what Marcel was indicating earlier as well. Originally, there's this triangle: it's the teacher, the artificial intelligence, and the learner. And somehow in these two models, we take one of these two perspectives without integrating the third. So I think it's a really important question to start thinking how we can integrate that in a broader perspective. And also really start thinking about where those boundaries lie if we want to complicate it with making a three-dimensional space, which in fact it is. For sake of clarity and for discussions, especially with primary and secondary school teachers, we found this two-dimensional model a little bit easier for them to understand and to position different technologies on, but I totally acknowledge that we should broaden the scope of that. And that different students will make different decisions, and also different autonomy levels are possible at different levels. So definitely good questions, and I think source for further discussions and great prototypes that show how we could integrate these different layers.
Thank you. Then I go back to the audience. So I think Simon, you have also raised your hand. Please have your question.
Thanks, Inge. Very nice presentation. Thank you. It's a helpful analogy to talk about autonomous vehicles, but there's at least one important difference between cars and drivers and AI and teachers. Now, we could probably think of all sorts of differences, right? Clearly, teaching is very different from driving, but the whole point about your framework is about teacher agency. And the clear message is, as we move to the right, agency is reducing.
Yeah.
But I think that there's an important dimension, which is that you can get open and closed AI tools. In other words, how much the teacher can configure the behavior of the tool. So I think that there is for some of these tools, the teacher is not locked out. They can configure the tool quite radically in a sort of planning stage, but then at runtime, the tool is in full automation mode. But the teacher can still step in and change things. And that's, without this dimension, we confound the sort of automation spectrum you've got with agency. It's more interesting for AI Ed.
Yeah, I think I totally agree with that. And I think that's a really interesting fourth dimension then that we're adding, is the temporality of the control in that notion. So thanks, Simon. I think that's a really good perspective. I think what we see currently, though, with technologies being used at scale, that the autonomy of teachers is really under pressure. In fact, that ability to interact with the system and to orchestrate it, if you like, before runtime is very limited or even non-existing, let alone it's not even made transparent how it's used and what it's actually doing. So I totally agree with that vision, and I would love that we would move that direction. But I think it needs a lot of work in transparency of the systems, in making that interaction mode prior to runtime, having that orchestration option for teachers, and giving them the professional development in order to be able to interact with that in a profound way. So I can see that, but I also think there's lots of work to be done if we look at the current tech development and the systems that are used at scale.
Thanks again. I see a question from Tina actually in the chat also about this discussion item. What is the most optimal form of AI in education? That it's very hard to answer this because it depends so much on the learning task at hand and to the extent of that task. So shouldn't the learning task also be part of the model to distinguish aspects of what can we actually automate and should automate and what not. I hope I interpreted your question right, Tina.
Tina's here, so I'm sure that she's capable of supporting
Yes.
that. Yeah, I think it's totally right. So the model reduces complexity, definitely. So there is the whole learning design space, the whole orchestration space that is behind all of this. And I think what the model can help us do is explain at a higher level where we are and what we're trying to accomplish, and also really discuss, and that's also why I put that boundary between human and artificial intelligence so central in this model, is to really discuss what is the connection between the human and the AI. And of course, in different application areas and with different technologies, that plays out very differently. But it's still a discussion of what the AI is doing, what the human is doing, and at which stage they're able to interact or negotiate that space. So I think that is the general message, indeed, of the message and the purpose of the model. And at the same time, I totally agree with you that there's lots and lots of complexity underneath that. That's also why I invited you to plot your own technologies and developments on the models to sort of see what that richness is that we have within this community. And I think there are so many examples that we have of good practices where we're exploring this space and where we're trying to develop systems that really support teachers and learners within the classroom. And I think it helps to put them on the model in order to broaden up that dialogue and discussion. So I see you nodding, but I'm totally happy to hear you.
Sorry, my internet connection was frozen for a second, so I hope I didn't miss anything essential at the moment. But I also see, well, some people in the chat also request whether you have more examples for fully automated systems. I would say maybe you find examples already in the Miro board if you look into that. But if you can list some, they are also interesting. We are slightly running out of time, but I would like to address the next question that I see, or two questions that are probably related, raising a bit also to a societal and ethical level from Corey Urlings and Ralph Klammer. The level of automation, it's also related to the differentiation between supporting learning and decision-making. Does a high level of automation also mean that the AI is responsible for decisions, such as educational track decisions? And maybe connected to that, also the question from Ralph Kamar, with AI, will institutions like schools also vanish in the long run?
Well, that's an easy one. I think the Corona crisis really showed the social value of schools. So I definitely think today, I already had the stand that schools won't disappear, but today I think we're also happy having students back in our classrooms and at our university. That I find that rather unlikely, but that's a personal take as a educational psychologist and teaching educational sciences. So that's definitely different from the technical perspective. And yes, to the other question, yes, I think we should be very careful about artificial intelligence making critical decisions about our students. And in fact, in some of these technologies that are being used at scale, predictive analytics play a really big part in determining the curriculum for students. And I think that is something that at least should become very transparent for teachers so that they can interact with it. And maybe we should think very carefully about AIs determining what your curriculum and what your pathway will be, especially because we know that predictive analytics aren't perfect and they're always very limited to their view of what they see of a student. So I would really like to enforce human in control on decision making. And I think in some of these systems currently already used, at least here in the Netherlands, there are definitely decisions made by the AI that I don't think should be made there. So I think this is a very important point to start discussing and also helping exploring professionals and teachers in raising that awareness that in fact some critical decisions are currently already transferred. And that they should really play that important role orchestrating and supporting learners. And at the end of the day, it's a legal decision as well. They're responsible for the well-being of their students. How can they be responsible for well-being of their students if they don't even know how the system functions that they're working with? So I think there is a long route for this community to explain how to do it well and explain and highlight cases where it's not going so well.
I see that there is still a lot of discussion going on in the chat. Unfortunately, we are running slightly late on the schedule already. So it's we don't have time to really address and answer all the questions, but I think you really triggered some interest in the community with your contribution, and we see that there is a lot of also controversial discussion, which is very good for such a new and innovative field, such as introducing artificial intelligence into education. So I think, again, I want to thank you very much for your contribution. If you have the chance to be around at the ECTEL further, I think it may be interesting for some of the participants to directly contact you and get into some discussion. Other than that, I think with the Miro board and all the contact information, interested people will still be able to find you and start any further discussion with you on related topics. So thanks again for your contribution. I think we're moving now into the coffee break, into the first coffee break of the session, which will be slightly shorter than you expected. And in 20 minutes, we will then start the next paper sessions, paper session 1 and paper session 2. Thanks again also the audience for all your active contributions. That was probably one of the most interactive keynotes I have been attending. Thank you all.
Thank you, Roland, and thank you for your attention.